Excellent. Okay, so today I want to continue our discussion in the collections framework and the generic types. And we're really going to focus in on sets, the data collection, the data structure of a set today, and how sets are used in Java. So a quick overview of this particular slideshow or lecture will be a quick introduction into what are sets. Then we'll talk about the set interface in Java. We'll talk about the hierarchy of the set interface in Java. We'll talk about features of the set, the implementation of set methods, and then finally, generic set objects. So a set in Java is an unordered collection of unique elements or objects. So that means sets differ from arrays or lists in two ways. Both list or array list or linked list or whatever list structure we were looking at is ordered, and it can have duplicated elements. Where sets are unordered, it doesn't maintain, there's no guarantee that when you insert something in there that the ordering will be maintained, and every element within the set has to be unique. You can't have duplications. So in other words, a set is a collection of elements that are not stored in a particular order, and you don't have control. And this idea of not storing in particular order means you don't have control over where they go. Even if you impute them in a particular way, the underlying implementation of a set can then go behind you and then actually organize it however it wants. Okay, let's see here. So let's use an analogy of sorts to kind of explain what the set data type might be. So consider this figure below where you have a set of books by topics and it's not arranged. A collection of elements is not stored in a particular order into a set, such as a collection of elements based without order but uniqueness. So here, if we were to go ahead and have our set with the elements of just blue and orange and yellow, green and red. And so this is a set of colors. The set of colors aren't in any particular order, and they're all unique. Okay, so we can add elements in a set. We can iterate over all the elements in a set. Our sets can grow dynamically when elements are stored in it. So those are shared behaviors that sets have that are similar to lists. We can also check whether a particular element is contained in a set. A set will not allow duplicate elements. That means an element can exist only once in the set. And if we try to add the same element that is already present in the set, then it won't get stored. It'll ignore that request to try to add that element to ensure that every element is unique. So a set in Java can be useful to remove duplicate elements from a collection. So sets hold a single reference to an object. It does not provide two references to the same object. So two references to null or two references to two objects, such that A and B, such that the equals method across the two objects. So if we did A dot equals B, if those return back true, then both A and B can't be in the set at the same time. So that's how we're going to define uniqueness in terms of eligibility of being in a set or not. And null, by definition, is can only have one instance inside of a set. Okay, let's talk about the set interface. So set is an interface that was introduced in Java version 2. It is a generic interface that's declared like this. So an interface set, and then we have the generic typing here, where E defines the type of whatever element is intended to be held in the set. So very similar to how the other collections are also generically typed. The Java set interface does not provide any additional methods of its own. It uses methods defined by the collection interface, but places additional restrictions on those methods. So let's talk about the additional restrictions that are put on these on the sets interfaces method. So for example, when set uses add or add all methods defined by the collection interface, it does not add an element to the set if the set already contains that element. So set interface does not provide any get method like list to retrieve elements. Therefore, the only way to get elements from the set is to do so using the iterator method. But this method does not return elements from the set in any particular order. So using the iterator, we can traverse only in the forward direction from the first to last element. And that's notionally first to last. It's not like an order. It's just the first one that we're given all the way into the last one that we're given. We cannot traverse over elements in a backward direction using the iterator method, because remember, backwards directions are given to us by the list iterator, and this isn't a list, this is a set. So we have to use the universal iterator. And backwards really only makes sense if it's ordered data anyway. Let's talk about the hierarchy of the set interface. So the Java set interface extends java.util collection interface. So the Java util.sorted interface extends the set interface to provide the sorted set of elements, and the three classes such as hash set, linked hash set, and tree set implement the set interface. And then we have the concurrent skip list set and enum set classes that also implement the set interface. So if we were to look at this, let's look at a diagram, because that might be a little bit easier to kind of see. And what I might do here is, let's do this. Let's copy this. I have some room here on the side. Let's modify this slide here so that we can actually see the text alongside. Perfect. And so here we can see that we have collection, right? Everything is a collection here. And then we have the set interface, which is what we're examining here. So this would be the only thing that the set interface extends is collection, and then anything that has a set-like behavior would then implement off of set. So say, for instance, we're going to look at a hash set, we're going to look at a linked hash set, and we're going to look at a tree set, which are all the concrete classes that we could actually instantiate that will implement set. Okay, let's talk about features of the set interface. So a set is a unordered collection of elements. That means the order is not maintained while storing elements. While retrieving, we may not get the same order as we had put them in. It is used to store a collection of elements without duplicate. So that means every element in the set is unique. Sets use a map-based structure for its implementation. We'll talk more about what a map is next week, likely after our discussion on sets. We'll actually talk about what maps are. But sets are like a special case of maps. It can be iterated by using the iterator, but cannot be iterated using the list iterator, right? Because it doesn't implement the list interface. Most of the set implementations allow adding only one null element. However, tree set does not allow to add a null element. Set is not an index-based structure like a list in Java. Therefore, we cannot access elements by their index position. And it does not provide any get methods like a list. So here, we really see with sets, we really see the motivation behind having that iterator to be able to traverse our data structure, because not all collections are ordered, which means you can't just index into them. You don't have random access into them. Okay, let's talk about the implementation of set. So set implementation. So Java Collections Framework provides three general purpose set implementations: hash set, tree set, and linked hash sets. So the hash set is a concrete class that implements a set interface. It uses a hash table mechanism to store its elements, and it is the best performing implementation. So if we'll go cover these and we'll talk about when to use each type, but if unless you need the data to be sorted or unless you need it to be the order to be maintained, then hash set is the one that you'd want to go for by default. Tree set is a concrete class that implements the sorted set interface, which is a sub-interface of set. It uses a binary search tree mechanism to store its elements, and it orders its elements based on their values. It is considerably slower than a hash set, but you get the benefit of it being sorted, it's sorting your data. And then you have your linked hash set, which is another concrete class that extends the hash set. It stores the elements using a hash table mechanism along with a linked list implementation. And so the advantage of this is that it still is like a set, so it guarantees uniqueness, but with a linked list implementation, it also allows you to guarantee an order is there for on your set. So these provide a little bit more functionality than hash set, but it is at a cost of performance. So I have a question. Do sets just predate lists or arrays, or are they just specialized? No, actually, arrays are probably the very first and most primitive of data structures that exist. And that's because if you think about what the concept of an array is that it's just a contiguous block of memory. So like, for instance, a variable, you could almost think of a variable, a single variable as a array of size 1. Right? Because it's a block of memory that can hold a value. And so what we then call an array is if we could have a block of memory that can hold more than one values. And when we declare that, the reason why typically with an array we have to declare what its size is because the JVM, the Java virtual machine, will allocate that block of memory and reserve it just for storage for whatever alias you give that array. So let's say we gave that array the alias of foo, and we said that the foo array will hold 10 strings. Then what JVM does under the seamed is it's going to go ahead and reserve a block of memory that can hold up to 10 string values. And so that's why you get an array out of bounds error. That's why you can't grow it out over time, is because it's very brittly hardwired to the addressable space inside of memory. And so what we started to do as we evolved as software developers is we try to decouple the logic of how we govern our data structures from the actual hardware implementation of how we're actually allocating memory. And so that's why we have a distinction between an array, which again, when we're talking about array, usually we are talking about how it's actually that contiguous block of memory versus a list, which is a very array-like thing, or an array is a very list-like thing, but a list is more abstract. We can define a list without it actually requiring a contiguous block of memory, because we give it definitions like, oh, a list is ordered, and so we have index numbers that we can use to access the elements in the array and in the list. And then we can have different implementations of lists. Like we can implement a list using an array as the underlying structure, or we can implement a list using a collection of objects that linked from one to the other to be able to traverse it. And so the list is the more abstract thing than an array. And so a set is a different type of data collection than a list. So I guess the answer to the question, do sets predate lists and arrays, or are they just specialized? They're specialized. They're a different tool of being able to collect data than what list provides. So in the first Java class, you learn how to use arrays, and that's a very convenient tool just to go ahead and put data into. But as you start to evolve in terms of your software development practices, and as you start designing out your applications, there's going to be different ways you can collect your data, and there's implications on which data container, what data collection you should use, whether it should be list-based or whether it's going to be set-based. I would argue that if the data that you're trying to manage inside your application is supposed to be unique, it's safer to use a set than a list, because a list you could accidentally add in. You would have to check to make sure that that element isn't in there. You don't have to do any checks with a set. Like if the idea is that you're maintaining, let's say you're maintaining a list of email addresses and you're just getting them from a form and you're putting them into a collection. Well, if you use a set collection, if the same user tries to register 15 times, you don't have to check to see if that email already exists. The fact that sets don't allow duplications means you could just use a set and then you don't have to do any checks on your own to see if it pre-exists. Does that make sense? Excellent. And so that's really going to be the thing as we keep uncovering all these different classes and interfaces inside of collections, is just to illustrate that there's multitudes of ways that we could store and access and read and update our data that we're managing over, that we're processing on top of. And really, it's one of the critical components about designing a good software system is selecting the right way of processing your data and storing your data, so that you don't have to go behind your data structure and then implement things because you selected like a list instead of a set, or you selected a list instead of a map. Okay, so let's talk more about the set implementation here. So it orders set implementation. It orders its elements based on the order in which they were inserted into the set. That is, elements in the hash set are not ordered, but elements in the linked hash set can be retrieved in the order in which they were inserted. Yes, that's what I had mentioned previously. This is the brief idea of set implementation classes. We will learn more detail about hash set, tree set, and linked hash set classes in further lectures. So let's talk about the set methods. So a set interface has the following various useful methods, such as add, remove, clear, size, etc., to enhance the usage of a set interface in the collections framework. They're all listed in the table. So set does add some methods that aren't already in the collections interface. And so here, let's take a look at the interesting one. So we have the ability to add, and we've seen this method before in collections, right? So this is just used to be able to add a specified element. We have add all, where you can give any type of collection. So we could have a list, for instance, because a list is a member of collections, an array list, a linked list, or a set, a hash set. Anyway, any collection can be passed in, and then they'll take all the elements from that collection and add it into our set. We have a size method that's going to return how many number of elements are in our set. We have an isEmpty method, which will return true or false on whether our set is empty or not. We have a clear method that will remove all elements from our set. We have a contains method where we can pass in an object, and it'll search our set to see if there is a object, if that object is in our set or not. We have a contains all, where we can pass it a collection, and it's going to return true or false if all of the elements inside of the collection are also inside our set. We have a remove method where we can pass in an object, and it will remove that object from our set if it's inside of our set. We also have a remove all, where we can pass a collection of objects, and it will remove all the objects from our set that are inside that collection. We have an iterator, an iterate method that will give us an iterator object so that we can actually traverse our set. We have an equals method where we can pass in an object and compare to see the equality between two different sets. And then we have a hash code, which is used to get the hash code value for the set, which would be like an ID number, which would be useful for serialization. Okay, so let's talk about generic set objects. So we can create a generic set object by using one of its 3 concrete classes. And so the 3 concrete classes for a set, because the set is an interface, so we can't instantiate it directly, but the classes that implement set are the hash set. So we see this in the first example here. And again, we can go ahead and use the generic typing here. And when you see the letter T, you would replace that with whatever the type you were wanting to manage at that time. So T is some generic type. We have a linked hash set and we have the tree set. And so an actual example, removing the generic label and actually replacing it with a concrete example would be like here, if we wanted to make a set that held integer values, or if we want to make a set that held string values. Okay, so let's set some example programs based on basic operations. So so let's do some set-based example programs based on some of the basic operations. So we have adding elements to a set, where we use that add method to return true if the set does not contain the specified element. And if the set already contains the specified element, then it will return false. So let's take a look at the source code. And so here, let's actually jump. So here, this is going to be our set tester 1. So let me go to my IDE for these collection of slides and actually open that one up. So set tester 1. Okay, so here I'm going to import from java.util the set interface. Now, if we actually want to start using the set interface, we'll have to go ahead and import one of the concrete classes as well. So we'll grab hash set, and we'll also grab the linked hash set from the util package. Then we'll define our class, set tester 1. We'll create a main method where we can go ahead and just build out an application that plays around with these collections. Here we'll create a new hash set, and this hash set will hold a string. So we'll store it as a set, right? Because again, we're talking about looking at our data from the set interface perspective. So we'll declare it as data type set, and then we'll go ahead and use the generic typing so that this particular set manages over strings, and we'll call this S. So the first thing we're going to do is say, hey, S, what is your size? And then we'll print that to the console. And then we'll go ahead and use the add method to add multiple strings, colors into our set. So we'll do orange, red, blue, yellow, green. And then what we're going to try to do is we're going to add 2 duplicate colors here. So we're going to add red and blue again. And so we're going to go ahead and print out the new updated state of our set. And what we should look for is if those duplications exist or not, and also if the order of the elements are the same as the way we put them in. Then after we do that, we will check to see if set equals black. So check if the black element is present in the above set or not. If it's not, we will add black, and then we will go ahead and then print out the new state of set. Then we'll create a new linked hash set. So a whole different type of implementation of set. We'll add some colors, white, brown, and red. Yeah. And then we'll use the add all method to add all of the elements in this collection into our original set, and then print out the new state of our set. So let me go here and actually run this. Okay, so here we can see that the size before adding elements is 0 when we do on line 9, when we're printing that out. And then we're going to print out the message unordered set elements. So let's look at the order that is given it to me: red, blue, yellow, orange, and green. And we have put it in the order of orange, red, blue, yellow, green. So you can see that the order is different than the way we imputed it, and there's no way for us to have control over that with a hash set. It's just a fact of sets. But here you could also see that we're also guaranteed uniqueness. So we could attempt to keep adding a duplicated item and the set just ignores it. It's like that item already exists in there. Okay, so black is then successfully added. So if we look at the new set, we could see that we've added black to there. And then we could also see that we've merged the second set, the linked hash set, into our set. And here we can see that we now have white and we now have brown, but the red value was pre-existing, so that would have been ignored. So let's go back. Okay, and I just have a slide that gives you the output so that you have reference to this later on outside of this lecture. Okay, let's do another example using set. Let's talk about removing an element. So we saw how we could go ahead and add an element. So let's actually play around with the remove method. So here I'm going to go to my set tester 2. I'm going to go ahead and import my set interface, and then I'm going to import my hash set class so I can actually instantiate a set. I'm going to create a class just to have a main method so I can actually create an application that runs, and here's my main method. And then I'm actually going to go ahead and instantiate a set. So I'm going to create a set variable of data type set. And again, I'm going to use the general generics typing to go ahead and say that this is a set of strings. And then I'll just give it a label of S, and this will be a hash set. The first thing I want to do is I want to check to see if the set is empty, and I'm going to print that out. I'm going to add in several colors: orange, red, blue, yellow, green, all the strings. Then I'm going to ask again if the set is empty. Now, clearly it shouldn't be. So I should then print out set is not empty, elements in the set, and then we're going to print out the set. Then we're going to remove the blue string, the string with the word blue in there, and then we'll reprint out the set to illustrate that we've removed that element. And then we will also check the size to see that the size of our set is dynamic, and it will go ahead and change as we mutate our set. So let's go ahead and run that, and we can see here that it's true that the set starts out as empty. The set is not empty when we check it again after adding elements. We're going to print out that the set has red, blue, yellow, orange, and green. And the set elements after removing blue are now just red, yellow, orange, and green. And then the total number of elements is now 4. So a good thing, like for instance, a set might be useful for is, say for instance, in the item system we're talking about. Suppose that you have things that are supposed to be unique. Like let's say you have you're managing over all the magic spells that could go into a spell book. And if a user, if like the player of your game, the user of your application can find scrolls to add to their spell book, but it doesn't make sense to have multiple entries of the same spell. Like let's say they find a fireball scroll and then another fireball scroll. Well, you can just manage the spell book using a set data class then. So when they add it in the first time, it gets added. And then if they add it in again, it doesn't do anything. I'll give you just an example of how maybe in a way that in a problem domain you've already been working on how you might decide to select a set over a list. Okay, and that's our output, which we just saw. Here, let's do another example of set based off of trying to search an element in the set. So let's make a program where we will search an element and use the contains method to see if that element is in the set or not. So let's go to our set tester 3 here. So here, in order to search for an element and see if there's an element in my set or not, I will import both the set interface and the hash set concrete class so I can actually instantiate a set. I will create a class so that we can have a main method so that we can actually run this application. Here, I'll create a new hash set, and I'm going to store it as a set data type. And I'm going to use the generics typing so that this manages over cars. And so we're going to add in some characters, D, F, H, P, K, and then we're going to add in null, and then we're going to add in null again. So we're going to duplicate that null element, but we know we can only have that one. Then we're going to print out the state of our set. And again, it's going to be unordered, so it's not necessarily going to follow the ordering that we added in here. Then on our set, we're going to call the contains method to query our set. Hey, does our set have the character A? And we're going to get back a Boolean response, and then we're going to print out that Boolean response, and that should be false, right? We didn't put an A into the set. But then after that, we're going to check, does our set contain a K? And then we'll print out, if it does, that the K is present. And we do know right here, line 10 says we did add a K. So we should get that print out. And if, for some reason that returns false, we have an else clause that will say, oh, okay, it's not in the set. And then we're going to go ahead and grab the set's hash code just to see what that hash code value looks like. So let me go ahead and run this application here. And we can see that we have our unordered set. So we have all the elements that are added, including null, and they're all unique. And then what we're going to do is we're going to check to see if the value of A is present, and it's false, right? We're able to get a false response on that. Whereas if we go ahead and use the contains method to see if K is in there, we get a printout that says K is. And then the hash code value for this set is 365. And that's the output there. Okay, so one of the motivating questions that you might want to be asking yourself is, well, when do you want to use a set? So if you want to present a group of individual elements as a single entity where duplicates are not allowed and insertion order is not preserved, then you should go for the set container, like a set collection. If your requirement is to get unique elements, then using a set is a really good choice for that. And if you want to remove duplicate elements without maintaining the insertion order from the non-set collection, you should go for a set as well. So you could take something like an array or an array list and pass it into the set constructor, and it'll automatically remove all the duplicated values because it'll turn into a set. So let's take a simple example program where we do remove duplicated elements from an array list right here. So that's going to be our set tester 4. So instead of looking at the slide, I'm going to use the IDE. And here we're going to import array list because that's what we're going to start with. We're going to import hash set because that's what we're actually going to build. And then we're also going to import set and list because we want to think of these things in their more abstracted form when we go to store them in memory. So we'll use the data type of list and the data type of set to go ahead and manage over our instantiated list and set. Then I'm going to create a class so I can have a main method. Then I'm going to create a main method so we can actually run this code. So the first thing I'm going to do is I'm going to start by creating an array list of integers. I'm going to check the array list size and I'm going to print it out. We're going to add a whole bunch of integers, 5, 10, then 5 again, 15, 20, 10, 20, and 30. So we have a collection, but we have 2 duplications. We have 2 instances of 5 and 2 instances of 20. Then we're going to print out our array list. Now we're going to create a set of integers, and we're going to pass into our constructor of our set the original list. So now we should have a set that contains these values, but the set will go ahead and automatically remove the duplicates. It'll also put in whatever order it wants as well. And then what we'll do is we'll print out the order of the set. So let's go ahead and actually run this code, make sure everything compiles and see how, and then here we can see the original order of my list elements is 5, 10, 5, 15, 20, 10, 20, 30. When I convert that array list into a set, though, we can see now the order is all different, and also it removed those duplications for me. So now my set has 20, 5, 10, 30, and 15. Let's see here. I have a question. They do not have a concrete way of set putting the numbers in a specific way. No, yeah, that's one of the things about sets, is that by definition they are an unordered container or collection. So whereas lists are designed to be ordered, like that's one of the defining features, sets are all about ensuring uniqueness, but they don't care about ordering. Whereas lists care about ordering, but they don't care about uniqueness. So they're kind of diametrically opposed in that way. If you can think of a collection as having like two different considerations, one is, can I have duplicated instances or a single instance? Should I be restricted to a single instance, or does the ordering of my elements matter, or does it not matter, right? Both of them don't care about one of those two considerations in a different way. Yeah, so one of the powerful things, so I have another follow-up question to that regard, but they're used to modify, sort other data containers by passing different collections through, correct? Yeah, like one of the powerful things about the collections framework is that everything is built from the collections interface. So as we get these concrete classes that have all these different behaviors, where set has its predefined behavior and a list has its predefined behavior, we can easily take a list and convert it into all the rules that apply to a set by just passing it into a constructor. Because every collection, I believe almost every collection constructor will take in a collection data type and then apply its rules in its instantiation. So it could be a very powerful way to, yeah, process data. Like, and I'll give you an example. Let me give you back another example of an item system. So suppose that you have a backpack inside of your inventory application that is modeled using a list. And the idea with a list is that you want to be able to organize the contents that's in your backpack, right? So if you're thinking something along the lines of an inventory, like either Resident Evil or Diablo, right? It's something that is almost Tetris-like, where you have to orient things. But let's say that, let's go back to the original suggestion I gave, where you collect, say, for instance, scrolls in your inventory. So you can have multiple instances of the Fireball scroll, but then you want to go ahead and take all the scrolls and then put them into the spell book. So that's an instance where you can pass your list, your inventory list, into your spell book set, and it'll automatically add all the new spells and remove the duplications of the scrolls. Does that help? Or does that answer your question or your insight? Excellent. Okay, so here we have yeah, so I'm trying to fit sets in with the other ones as far as purpose is another comment that I have here. And so, yeah, like this is probably your first introduction to a different type of way of containing data, of organizing your data than you've seen before, right? Like you probably only have experienced arrays, and arrays are very list-like in their definition. But the idea behind what motivates a set is going to be the concept of uniqueness. So if you know that there's something unique, that you only need one instance of a value in your collection, and that value can be imputed a lot of times, then set's a really good choice. I'll give you an instance of an application that I had wrote once where set was a preferred thing. So it was a graphics user interface, and I wanted to control a character based off of button clicks. Let's say it was like a WASD control, so WASD, where W would move my character up, S would move my character down, A would move it to the left, and D would move it to the right. And so the idea of what I wanted to do was I wanted to capture when the user was pushing that key down and store it in a collection, and then see if this collection had a W in it. Then I wanted to then tell the character in the application that its move up method should be called. And if the W wasn't inside of that like move set, then I didn't want to invoke that method. I only want to invoke the methods for each iteration of my game loop for when the WASD was present. Now, this is the thing. Set works really well for that, because the time cycle that a user hits the W key, when even if you just push it really quickly, your game loop could be running like 60 times a second. And so if you go to push a button, it could, even if you just quickly push and then let go, and most of the time when people are moving, they're pushing and holding the button, you don't want to keep adding duplicated values of W in there, because that's going to grow the size of your list to be really large. If I just press and hold W, it would add it and then add it. It adds 60 W's in just a second, just to have the character move up. And so if I were to implement using a list, I would have create a big memory leak there. My application might eventually crash if my array grew, my list grew so large, because it kept holding on to those duplicated values of W. Whereas with a set, if I input the W into a set and then remove it after the key is depressed or unpressed, then I only ever put one W in at any time. I'm not allowed to put in additional W's. Does that make sense? How that motivated my choice of whether I should use a list or set? Okay, so a quick pop quiz on sets. So assume that set one is a set that contains the string elements such as banana, orange, and apple, and set two is another set that contains the string elements such as banana, orange, and mango. What are the elements of set one and set two after executing set one dot add all and then set two? Well, it should be the combination of these, right? But only a singular instance. Okay, what are the elements of set one and set two after executing set one dot add set two? Not add all, but add. And so this probably isn't the method you want to be calling there. What are the, because that set two is a collection, not an individual string. What are the elements of set one and set two after executing set one dot remove all set two? So here it would remove anything that wasn't set two from set one. What are the elements of set one and set two after executing set one dot remove set two? And again, here, this is we're passing our collection in. I wanted to remove all here. And then what are the elements of set one and set two after executing the retain all method? We'll talk more about the retain all method in the next slideshow, I believe. What happens if we call clear? And then what is the size of set two after executing set two dot add mango, which mango already existed? And then I just have my follow-up answers here. So when you run through this, this gives you an opportunity just to challenge yourself to see if you have a strong understanding of what's going to happen. Excellent. And so that's going to be the, let's see, that's going to be the lecture on set interface.